So if you think about when a composer composes music, or when you compose something, you're creating. So what we're going to do is we're going to take two functions and we're going to compose a new function out of them. So we're going to take one function and we're going to put it inside of another function. Now this is similar, or the same thing actually, as what we were doing when you had something like f of 3 or f of 5 or f of -2. We took those values and we put them in place of x. Well, this time, instead of a value that we're going to put in, we're going to replace x with a function, okay, a g of x. So instead of a 2, it may say g of x. So you're still filling in for the x value. It's just that what you're filling in is no longer a number, but is a function. All right, so remember, think back to when we first started talking about functions and we were talking about filling in that value. We said when we fill in a number, we get out a number. All right, so this time when we fill in a function, we should get out a function. Okay, so let's take a look at composition of functions. All right, so to know when they're wanting you to do a composition of functions, it's going to look one of two ways. It may say f, and that little circle is not a 0 or a degree symbol. It means f composition g. All right, f composition g of x means to take, or you may see it written like this, f of g of x. So it means to take the function g and to fill it in to the function f. All right, this would be read as g composite f. All right, f composite g, g composite f. That's how we would read it. Or you may see it written in this notation, g of f of x, where I would take the function f and fill it into the function g. Okay, so let's take a look. We have two functions, f, which is the square root of x plus 4, and g, which is 2 over x. And we're going to do the composite of f composite g. We're going to do that first. So f composite g, it looks like fog, is the same thing as f of g of x. So this is telling me I'm going to take the function g and fill it into the function f everywhere there is an x. So the function f is the square root of x plus 4. So if I come over here and I say the square root of x plus 4, but instead of x, I'm going to put the function g. So instead of this x, I'm going to replace it with this, 2 over x plus 4. Okay, and this is now f of g of x. Next, they want me to find f of g of 2, so it's going to look like this, f, all right, f of g of 2. So I'm going to take that 2 and I'm going to fill it into my function here. So here's my function, 2 over x plus 4. In place of x, I'm going to put the number 2. So instead of writing this x, I'm going to replace it with 2. Then I'm going to simplify it. So 2 over 2 is 1 plus 4 leaves me the square root of 5. Alright, so first we found f of g of x by taking the whole entire function g and putting in place of x in the function f. So here's the function f, the square root of x plus 4. Instead of writing the x, we replaced it with 2 over x. That gave us this function here, f of g of x. Then they ask us to find what is the value of f of g of x when x is 2. So now that I'm putting in a number, I should get out a number. So I come down here and I put in place of x a 2, simplify it to get 1 plus 4. That gives me the square root of 5, which is, if I put that in my calculator, a decimal, and I cannot simplify it any further. Alright, so here are the two answers we were looking for. The square root of 2 over x plus 4 is f of g of x, or f composite g, and then f of g of 2 is the square root of 5. Alright, let's try that one more time. This time here at the bottom we have we want to find g composite f, or g of f of x. Okay, so I'm taking a function and filling it into a function. I should get a function out. So g of f of x means I'm going to take the function g. Sorry, let me start that over. G of f of x means that I'm going to take the function f and fill it into g. So first I'm going to take g and write it out, and everywhere there's an x I'm going to leave it blank. So remember, g is 2 over x. So we're going to write that down first. 2 over, but in place of x, I want to put f of x. So instead of writing the x there, I'm going to come up here and get what f of x is, which is the square root of x plus 4. So square root of x plus 4. And that would be the function g of f of x. Now, if I want to find g of f of 5, as it states here, all right, then I simply fill in the 5 everywhere there's an x in my new function. All right, so here's my new function, 2 over the square root of x plus 4. So in place of x, I'm now going to put a 5. 5 plus 4. And that will give me 2 over the square root of 9, which I can simplify, so that'll be 2 over 3. All right, let's look on the second page here. All right, this one asks us to find f of g of x and then give the domain. Okay, so we want to find what is our new function and then what are all the x values that can go in that function. Let's see if I can get it to focus here. Okay, so f of g of x, we're going to take this f of g of x. I'm taking what's inside and we'll fill it into f, and so they're asking me to replace all the x's with the function g. Alright, so here is f, the square root of x minus 1. So in place of x, I'm going to put the function g. So instead of writing this x here, I'm going to write 2x plus 5 and then subtract 1. Then when I simplify it, I get 2x plus 4. Okay, so that is my new function, f of g of x. I want to know what is its domain. So I look to see what type of equation in it is it. We've talked about linear, we've talked about square root, we've talked about rational, all three of those. So when I look at this, this is a square root function. So I know that whatever I fill in for x can't make what's under that radical sign be a negative. I know that whatever I get under this radical sign has to be 0 or greater, because I can only take the square root of 0 or positive numbers. So I'm going to take what's under here, 2x plus 4, and set it greater than or equal to 0, and then solve for x. So I'll subtract 4, and then divide by 2 to find that x can be anything greater than or equal to negative 2. If I write that as interval notation, I'll have a bracket, negative 2, comma, positive infinity. All right, let's look at the next one. Next, I want to find g of f of x and give its domain. So this time I'm looking for g of f of x. So I'm going to take the function f, fill it into the function g, and create a new function. Okay, so the function g is 2x plus 5. 2x plus 5. This is g, but instead of putting that x there, I'm going to put the function f, which is the square root of x minus 1. So then when I simplify that out, I get 2 square roots of x minus 1 plus 5. You can't multiply the 2 times the square root of x minus 1. The only way you can multiply radicals is if both factors that you're multiplying are radicals. So it would have to be square root of 2 times square root of x minus 1 before I could multiply those together and get square root of 2x minus square root of 2. okay? So this is as simple as we can get it here. So when I want to find the domain, I look to see what type of equation is it. All right, my variable x is under that square root. So I'm going to have some limitations here as to what x can be because I can't get a negative number under there when I fill in x. So I'm going to take out what's under there and figure out what will make it be 0 or bigger. I add 1 to both sides to find that x can be anything 1 or greater. To write that in interval notation, we do bracket, the number 1, comma, positive infinity.